Hello students, I trust you've been enjoying the class. Please don't forget to subscribe and hit the notification bell so that you'll be notified whenever a new content is uploaded. And don't also forget to like, to share, and to leave us a comment. Thank you very much. Now, we'll be going to the next question, that is number 41. The reason for laminating the soft iron core of a transistor is to, the correct answer is A, to reduce eddy current. Now, the soft iron core of a transformer is laminated in order to reduce the phenomenon of eddy current. So the correct answer for number 41 is A. Let's go to number 42. Formation of hydrogen bubbles at the copper plate of a primary cell is called, the correct answer is polarization. We define polarization as the formation of hydrogen bubbles at the copper electrode. That is what polarization is. Don't forget that polarization and local action, which is option D here, polarization and local action, these are two defects of primary cell. But whereas polarization is the correct answer here because it is called the accumulation of hydrogen bubbles at the copper plate. Local action, on the other hand, is caused due to the presence of impurities in the zinc electrode. Now, how do we prevent polarization? By using a substance called a depolarizer. Different primary cells have different depolarizer. For example, the dry Lagrange cell possesses a different depolarizer from a Daniell cell. In the case of a Daniell cell, the depolarizer that is used is copper 2 sulfate, CuSO4, whereas in a dry Lagrange cell, the depolarizer that is used is manganese 4 oxide, MnO2. Whereas if it's local action, how do we prevent or minimize local action? By rubbing the surface of the impure zinc with mercury, a process called amalgamation. So local action can be prevented or minimized by amalgamation, while polarization could be prevented or minimized by depolarization. So the correct answer for this is option A. Let's go to number 43. Which of the following factors does not affect the rate of evaporation of a liquid? The temperature does affect the rate of evaporation. As a matter of fact, the higher the temperature, the faster the rate of evaporation. Wind also affects the rate of evaporation. The faster the wind blows, the faster the rate of evaporation. The same thing, surface area. The more surface area of the fluid is exposed to atmosphere, the higher will be the rate of evaporation. But the volume does not affect the rate of evaporation. The rate of evaporation is independent on the volume. Either a smaller volume or a larger volume, it doesn't affect in any way the rate of evaporation. The correct answer for number 43 is B, volume. Let's go to number 44. The opening in the eye through which light passes to the retina is called option A. That's the pupil. Pupil is that particular opening in the eye through which light enters and goes into the light sensitive part of the eye called the retina. So the correct answer is pupil. Don't forget that iris is the colored part of the eye. So if the question asks for the colored part of the eyes, the answer would be iris. But the question is asking for the opening in the eye through which light enters and gets to the retina, which is the pupil. So the correct answer for number 44 is option A, the pupil. And the optic nerve, the transport or the carry the optic nerve carry impulses from the eyes to the brain for interpretation. The correct answer once again is option A. Number 45. A heat-sensitive resistor made of a semiconductor is called a thermistor. That's option C. A thermistor is a heat-sensitive resistor made of a semiconductor. That's option C. Don't forget that a thermistor is also an example of a non-ohmic conductor. Because there are some material that obey Ohm's law, we refer to them as ohmic conductors. What are they? All metals are ohmic conductors. You still remember what Ohm's law tells us, that the voltage or the potential difference passing through a conductor at constant temperature is directly proportional to the current passing through it. Remember, the resistance is constant in Ohm's law. So those materials, like all metal that obey Ohm's law, we refer to them as ohmic conductors. And materials that do not obey Ohm's law, we refer to them as non-ohmic conductors. Examples are semiconductors, like silicon, like germanium. They are non-ohmic conductor. We also have diode. A diode is a non-ohmic conductor. We have a transistor. A transistor is basically used as a switch and also as an amplifier. A transistor is also an example of a non-ohmic conductor. So also a thermistor is also a non-ohmic conductor, and electrolyte is also a non-ohmic conductor. So number 5, the correct answer is C. A thermistor is a heat-sensitive resistor made up of a semiconductor. Let's go to number 46. Electric motor primarily converts, that's electrical energy, into mechanical energy. That's what an electric motor does. An electric motor converts electrical energy into a mechanical energy. That is option C. Electric motor primarily converts electrical energy into mechanical energy. Option C is the correct answer. Number 47. Which of the following statements about the molecules of solids and liquid is correct? They both, option A, have weak attraction? No. It is the molecules of gases that have weak attraction. Option B, have wide separations? Not at all, because the molecules of liquid and solid are actually very close together. So the separation between them are actually very small, not wide. Option C, exhibit random motion? No, it is the molecules of gases that are moving at high speed and they are moving randomly. So the correct answer is D, exhibit vibratory motion. Because the molecules of most liquid and solid are very close together, and because of the bond holding them together, they are unable to move from one place to the other. They only vibrate about their main position. So that is the meaning of the exhibit vibratory motion. The correct answer for number 47 is option D. Number 48. The distance between a node and its adjacent antinode of a transverse wave is equal to that. First of all, what is a node? A node is that particular point of minimum displacement or almost zero displacement in a wave, while an antinode is the point of maximum displacement. Let's take a look at the board and see how this can be made more easier to understand. So if you look at this, here, this is the node. This, a fixed point. The middle point here, that's the antinode. The fixed point here, that is also node. Don't forget that the distance between adjacent node is half of a wavelength. Take note of that. The distance between adjacent node is the half of a wavelength. We know wavelength is lambda, half of a wavelength. But the question is asking us, what is the distance between a node and adjacent antinode from air to air? Since air to air is half of a wavelength, then air to air is also half of air to air. So between node and adjacent antinode is going to be half of lambda all over 2. That gives us lambda all over 2 times 2. That's 4. That's going to be a quarter of a wavelength. So the correct answer is going to be option D, quarter of a wavelength. All right, number 49. The acceleration of a moving object can be determined from the dash. Is it A, slope of its distance time graph? No, because the slope of a distance time graph will give us the speed. The correct answer would be option C, slope of its velocity time graph. When we find the slope of the velocity versus time graph, we obtain the acceleration of the body. So for number 49, the correct answer is option C. Let's go to number 50. A student wishes to measure the potential difference across a resistor R. She has a galvanometer G and some connecting wire. What else does she need? Basically, this question is asking us, how do you convert a galvanometer G to a voltmeter since the student wishes to measure the potential difference? And we know that galvanometer can be converted to a voltmeter by connecting a high resistor, that's R, in series with it. So if you look at the options now, that's going to be option D, high value resistor connected in series with the galvanometer. Once again, a galvanometer can be converted to a voltmeter by connecting a high resistor called a multiplier in series with it. So that makes option D the correct answer. As an addendum to this, we can also convert a galvanometer to an ammeter. How do we convert a galvanometer to an ammeter? By connecting a low resistance called a shunt in parallel with it. So don't forget, the correct answer here is option D. Hello students, I trust you've been enjoying the class. If so, please hit that subscription button and turn on the notification bell so that you'll be notified as soon as we have a new content. Don't also forget to like, to share, and to leave us a comment. Thank you very much. Now let's go to the next question. That will be number 51. Which of the following units is equivalent to the unit of electric current? The correct answer here should be A. Let's see if A is indeed the correct answer. Remember that the quantity of electricity, which is Q, is equal to current in ampere times time in seconds. Now, if we make our current the subject of the formula, current now is equal to Q, that's the quantity of electricity in coulomb, divided by time in seconds. The unit of quantity of electricity or quantity of the charge here is coulomb, that's C, all over the unit of time, that is seconds. This could also be written as C S raised to the power minus 1. So that is the correct answer, which is definitely option A. So the correct answer is coulomb per seconds, option A. Let's go to number 52. A ball is swung in a horizontal cycle of center O with a constant speed. What is the direction of its acceleration? Whenever an object moves around a cycle with a constant speed, the acceleration is always directed towards the center of the cycle. So the answer is option C, towards O. Don't forget, O is the center of the cycle. Alright, so that's that. That's the correct answer, option C. The acceleration will be directed towards the center of the cycle. C. Number 53. We are given this AC circuit. The diagram above is an illustration of an alternating current circuit. We are to calculate the reactance of the capacitor, that is capacitive reactance. Let's look at the board and see how we can solve this. So if you look at the board, we can see that the capacitor is given as 5 microfarad. This is equal to 5 times 10 to the power minus 6 farad. That's the meaning of the micro here. And we are given the frequency to be 500 over pi hertz, 500 over pi hertz. Now that's all we need. Don't forget, we are asked to calculate the reactance of the capacitor, that is XC. We know XC is equal to 1 all over 2 pi FC, which should be 1 all over here, 2 pi. We don't need to substitute for the value of pi because that pi will be able to cancel this out, times F, which is 500 over pi. That's 500 over pi. That's what I was talking about earlier. They can cancel each other out, times the capacitor, which is 5 times 10 to the power minus 6. So our XC now is 1 all over this, cancels this. What do we do now? This multiplied by this. 2 times 500 will give us 1,000. 1,000 times 5 times 10 to the power minus 6. Don't forget the unit is ohms. And this can give us 1 all over. If you multiply this and this, that will give us 5 times 10 raised to the power minus 3. Everything in ohms. And then finally, XC is equal to, if we use a calculator to divide what is 1 divided by 5 times 10 to the power minus 3, that will give us 200 ohms. This is 200 ohms. So the capacitive reactance XC is 200 ohms. And if you look at the option, That is option C. So option C is the correct answer. Let's go to number 54, please. A current of 2 ampere passes through a wire of resistance 4 ohm for 3 minutes. We have to calculate the energy loss. Now, this is under electrical energy and power. We know that if you want to calculate the energy loss or the energy dissipated or the heat dissipated in a particular conductor, there are several formulas that can be used depending on the information we are given. Here, we are given the current, which is 2 ampere. We are also given the resistance R is equal to 4 ohm. I'll be given the time, which is 3 minutes. Don't forget, the time has to be converted to seconds. How do we do that? By multiplying this 3 by 60. That's 3 times 60 seconds. And our time will now be 3 times 60 seconds. It gives us 180 seconds. Now, the heat given off will now be I squared RT. This is one of the formulas that we can use. Don't forget, you can also say H is equal to IVT. We are only going to make use of this formula when we are given the current, the voltage, and the time. Or we can also say that H is equal to PT. We can only use this when we are given the power and the time. Or we can say that H is equal to V squared T all over R. We are only going to use this when we are given the voltage, the time, and the resistance. But we are sticking with this formula because these are the parameters we are given. The current, I, the resistor, which is R, and then the time, which is 180. So if you substitute here, the heat dissipated or lost will now be I squared. That is 2 squared. That's 2 squared times R, that's 4, times time, that's 180. Remember everything in joule. So this gives us 2 squared is 4 times 180. Everything in joule. So finally, let's use a calculator to find out what the answer will be. That's 4 times 4 times 180. And that gives us 2,880 joule. 2,880 joule. And if you look at the option, that is option C. So option C is the correct answer. Let's go to the next question, number 55. Which of the following statements about the universal gravitational constant G is true? Which of the following statements about the universal gravitational constant is true? It is a fundamental quantity. We know it is not a fundamental quantity. We have 7 fundamental quantities. We have the length. We have the length measured in meters. We have the mass measured in kilogram. We have the time measured in seconds. We have the mole. That's another one. We also have candela and the rest of them. So A is definitely not correct because universal gravitational constant is not a fundamental quantity. Option B, its SI unit is Newton meter cube kilogram raised to the power minus 4. That is also not true. I'm going to show you in a short while. And it is also not a vector quantity. It is a scalar quantity. So the correct answer is its dimension is m raised to the power minus 1, L cube, and T raised to the power minus 2. Let's see how this is the correct answer. First things first, you remember that in Newton's law of universal gravitation, F is equal to G m1 m2 all over r squared. All over r squared. Don't forget that Newton's law of universal gravitation tells us that every object in the universe attracts each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. Now, this capital letter G here is the Newton's gravitational constant we are talking about here. If you make it this formula, what do we have? We now have G is equal to F R squared all over M1 M2. First things first, let's find what the unit is so that we can compare it with the unit we have in option C here. The unit of force is Newton. The unit of R is meter, so meter squared, that's for R squared. Then divided by the unit of mass is kilogram. So we have two masses here. That's going to be kilogram all raised to the power 2. And this could be written as Newton meter squared, then kilogram raised to the power minus 2. This is the unit of the Newton's gravitational constant. So we can see it is not option C here. So let's take note of that. Now, let's see what the dimension will be, or how do we obtain this particular dimension. We can do that even from this unit. The unit, once again, is Newton meter squared, then kilogram raised to the power minus 2. Now, we know that Newton, the force as the unit, which is Newton. So force, what is the dimension of force? Don't forget that force is equal to mass times acceleration. And don't forget that acceleration is velocity all over time. Mass is kilogram, that's m. Then the dimension of acceleration is Lt raised to the power minus 2. So for force, the dimension of force is m Lt raised to the power minus 2. Then for meter squared, that's going to be L raised to the power 2, because meter is talking about the length. That's L squared. Then kilogram, that's kilogram raised to the power minus 2. Don't forget, what does this particular m represent? It represents the kilogram as well. So this particular kilogram can be written as m raised to the power minus 2. That's the mass. That's why we're changing the kilogram to the mass. So if you look at this, this is m, this is m. If you multiply this and this together, don't forget that m raised to the power minus 2 can be written as 1 all over m squared. So if you multiply by this m here, that's going to be times m. This, we just cancel this, and then you now have 1 all over m. So this becomes m raised to the power minus 1. Then this is L, this 1L multiplied by 2L here, that gives us L raised to the power 3. And then this is T raised to the power minus 2. So that is the dimension. And if you compare it with what we have in option B, we will see that m raised to the power minus 1 here, L raised to the power 3 here, and T raised to the power minus 2. So the dimension of the Newton's gravitational constant is m raised to the power minus 1, L raised to the power 3, and 3 raised to the power minus 2. That makes number 55 to have the correct option B. Let's go to number 56. Hello students, I believe you've been enjoying the class this far. Please don't forget to subscribe and hit the notification bell so that you'll be promptly updated whenever a new content is uploaded. Don't also forget to share and to leave us a comment. Thank you very much. Now, let's go to the next question, number 56. Which of the following curved surfaces will produce a real image? Concave mirror will produce a real image, absolutely. Convex mirror, always, irrespective of the object distance, a convex mirror always produces a virtual, a diminished, and an erect image. So convex mirror will not produce a real image. What about a divergent lens? A divergent lens is just like convex mirror. It always produces a virtual image. A convergent lens, on the other hand, will also produce a real image. So the question is, which of the following curved surfaces will produce real images? And then the answer will be Roman figure 1, that's concave mirror, and Roman figure 4, convergent lens. Let's take a look at the options. That's option D, 1 and 4. Only concave mirror and convergent lens will produce real images. Convex mirror and divergent lens will produce virtual images. Let's go to number 57. The components of vectors Q and R are given as follows. That's 3.0 and 5.5, then 9.2 and 4.4 respectively. We are to determine the component of vectors Q plus R. Let's come to the board and see how we can do this. So the component of Q is minus 3.0 and 5.5, while the component of R is 9.2 and 4.4. 0.4. Now, if you convert this into vector form, Q here now becomes, this one becomes minus 3I plus 5.5J. The same thing, this now becomes 9.2I plus 4.4J. So we are now asked to calculate the component of Q plus R. Q plus R. If you now add this and this together, so we now have minus 3I plus 5.5G plus 9.2I plus 4.4G. What do? We add the common factors together, this I. So this gives us minus 3I plus, we add it to this, 9.2I, then plus we add 5.5J and 4.4J together. That's 5.5J plus 4.4J. We will do that, then our Q plus R, this is Q plus R, don't forget. So if we add this and this together, what do we get? We get 6.2I plus 5.5 plus 4.4, 9.9J. So the component of Q plus R now would be, all you need to do now is just remove the I and the J. We now have 6.2, 9.9. So if you look at the option, which option satisfies that? That is option B, 6.2 and then 9.9. The correct answer for 57 is option B. Let's go to number 58. Which of the following arrangements of radiations below shows decreasing order of wavelength? Don't forget, decreasing order means that we are supposed to start with the one that has the highest wavelength and we are going to end it with the one that has the lowest wavelength. So if you look at this, X-ray, as a matter of fact, the fact that X-ray is starting it makes it to be wrong because X-ray has one of the shortest wavelengths. As a matter of fact, the only part of the electromagnetic spectrum that has a shorter wavelength than X-ray is the gamma ray. So X-ray is out of it. The correct answer here would be option B. Radio wave has the longest wavelength in the electromagnetic spectrum. So radio wave has a higher wavelength than the infrared radiation, and infrared radiation has higher wavelength than X-ray. So the correct answer is option B. Don't forget, if I know about the electromagnetic spectrum, we have various components in them. We have the gamma ray, it has the shortest wavelength, followed by the X-ray, then we have the ultraviolet ray, then we have the visible light, and then we have the infrared, and then we have the radio wave. So if you want to arrange them, all of them in decreasing order of their wavelength, we have to start with radio wave. Radio has the longest wavelength, followed by the infrared. Then after that, we come to the visible light. After that, then we come to ultraviolet light. And then after that, we come to X-ray. And then finally, we come to gamma ray. So for emphasis, the correct answer is option B. For 58. Let's go to number 59. A wire of cross-sectional area 2 pi times 10⁻⁸ meters squared and resistivity 1.1 times 10⁻⁹ ohm meter has a resistance of 21 ohm. We have to calculate the length of the wire. We have to take pi to be 22/7. Let's come to the board and see how we can solve this. Don't forget that the resistance of a wire is directly proportional to the length. Not only that, the resistance of a wire is inversely proportional to the cross-sectional area. So if you combine these two equations, it means the resistance of a wire is now directly proportional to L and then inversely proportional to A. Now, if you introduce a constant, then we now have our R is equal to KL over A, where K here is constant, and this particular constant is called what? The resistivity of the wire. So if you want to calculate our L, remember that is what we are asked to calculate. We just need to make L here the same formula. How do we do that? We can constantly apply, and we now have 1 times KL. That's KL is equal to R A. Don't forget this K, which is a constant, is resistivity. Resistivity. So if you divide both sides by K, the resistivity, then we now have our L now is equal to R A all over K, which is the resistivity. So if we continue with our question here, it means our length now is the resistance of the wire has been given to be 21 ohm. That's 21 ohm. You don't need to put that there, times the area. The cross-sectional area of the wire has been given to be 2 pi times 10 raised to the power minus 8, then divided by K, which I told you is the resistivity. I've been given the resistivity to be 1.1 times 10 raised to the power minus 8. So, first things for 10 raised to the power minus 8 cancels 10 raised to the power minus 8. Don't forget the length to be measured in meter. L now is here, that's 21 times 2 times pi is 22 all over 7. Everything divided by 1.1 in meter. So 7 here, 1. 7 in 21 is 3. So that the length now is 3 times 2. That is 6. And then 6 times 22, 6. 6 times 22. That gives us 132. So that's 132 divided by 1.1 meter. So if you divide 132 by 1.1, that gives us 120 meters. So the length of the conductor or the wire is 120 meters. And if you look at the option, that is definitely option C. So the correct answer for number 59 is option C. Let's go to the last question, which is number 60. Which of the following statements best describes particles in a solid at room temperature? They are far apart and moving randomly. That does not describe the particles of a solid. This option A describes the particle of a gas because the intermolecular space between the gas molecules are wide and they move randomly. Alright? Option B, close together and vibrating. That's the correct answer here. Because the molecules in a solid are held together by strong forces, they are unable to move. They are only vibrating about their main position. So they are close together and vibrating. That is the correct answer. Number 60, the correct answer is option B. We've come to the end of this physics class today. We appreciate you for sticking with us throughout the class. Please don't forget to subscribe and hit that notification bell so that you'll be notified whenever a new content for your benefit is uploaded. Don't also forget to share and to leave us a comment. Thank you very much. See you in the next one.